Hi, I want to talk about some other ways to find missing sides. One of the things we learned in doing a 30, 60, 90 triangle, which is basically, once again, half an equilateral, is obviously this is 10, this will be 20, but the relationship between these two, so I multiply this by the square root of 3, which is about 1.73, that'll give me this number. Another way to do this is any size 30, 60, 90 triangle is this relationship is going to be the same. That square root of 3 is going to be the same, but there's another way I can express that. I can express it as a ratio. And if we want to think about it, if I'm looking at the 30-degree side, this side over here is opposite. This side here is what's called adjacent. And this side is always the hypotenuse. Hypotenuse never changes. Okay? So I can set up a ratio of like opposite to adjacent. So if I have other 30, 60, 90 triangles, I can say, well, what's the ratio? What's one of the numbers? And then kind of cross multiply, figure out, okay, what's the other missing number? So in this case, my opposite over adjacent ratio for any 30, 60, 90 triangle going from the 30 degrees, because it's important, because the ratio from the 60-degree angle is going to be different because I've got a different opposite to adjacent from the other one. But from that angle, that's opposite, that's adjacent. So it is 10 over 17.3. And when I put that in my calculator, I already did it. It is about 0.58. So the relationship between these two is for whatever the opposite is, or whatever the adjacent is, the opposite is 0.058. Think of this as 0.05 over 1. If the adjacent is 1, the opposite will be 0.58. It's a great way to think about it. So if I give you another 30, 60, 90 triangle, so maybe I give you another one that's like this, and what did I decide to make it? If I just let's say it's 20. Now we know what the answer is going to be already, because it's twice as big, and it's we know that these are similar triangles. But just to show you how the math would work, say I didn't know that, I say, oh, if this is 20 and I'm going from the 30-degree angle, and I know this is the ratio for 30 degrees and opposite over adjacent, then I can use that fact to say, oh, well, if this is 20, opposite over adjacent is always 0.58 for the opposite if the adjacent is 1. But in this case, I actually know the opposite. The opposite here is, I'm just going to scratch that out. I'm going to change colors. I'm going to say, okay, my opposite was 20, and my adjacent, that goes here, my adjacent is what I'm trying to find out. It's right there. So now I can cross multiply. I can say, oh, 20 times 1, and 0.58 times A. And then when I divide both sides, I get A is equal to, I don't know if I did this ahead of time or not, 20, I'm dividing off the screen, divided by 0.58, which is 34.5. And the question might be, okay, 34.5, I was actually expecting 34.6. And this is because that 0.58 is rounded. If I'd taken it to a couple of other decimal places, it would have gotten us closer to the 34.6. But the idea is basically here, for any 30, 60, 90 triangle, if I'm going from the opposite side to the adjacent side, I can set up an opposite over adjacent proportion. Whichever number I'm missing, I can plug in and find the other number, because the adjacent, if the adjacent is 1, the opposite will be 0.58, and then for any other triangle that's 30, 60, 90, it's going to have that same proportion, so I can just plug in my missing number and find what the other one is. Okay, so we already knew that, so that seemed pointless. Let's do it for one we didn't know. Okay, so let's say I have a 2367 triangle. Now I actually did this on Desmos and found out like what are the exact numbers that I would get here for this kind of triangle. You'll notice in our previous one, this was 20 and this was 34.5. In this one, it's bigger, which makes sense because this angle got smaller, this side got smaller, this side opened up more, so this one's going to be bigger. It's bigger angle. So for the 20 here, going to get a much bigger one over here. So it's a different ratio. So let's figure out what that ratio is. Let me make sure I'm following my notes here. Well, there's three ratios I can do here. I can do opposite over adjacent. I can do, so once again, we're going to start from the 23. Okay, that's opposite from the 23. This is adjacent, which I'm going to write out because we haven't seen that number word a lot. And this is always, once again, the hypotenuse. So there are three things. If I'm wanting to move back and forth between these two, there's a ratio. Between these two, there's a ratio. Between these two, there's a ratio. So I can figure out all three of those. So let me just start with opposite over adjacent. Opposite over adjacent is going to be 20 over 47.1. And I've got that written down somewhere. That's 0.42. Or I can think of it as 0.42 over 1. So if my adjacent is 1, my opposite is 0.42, which makes sense. This is smaller, this is bigger, this is about half, which that ratio makes sense. If I do my adjacent over my hypotenuse, so my adjacent is 47.1, and my hypotenuse is 51.2. So when I divide those, I have, let me find it over here, it's 0.92, and I can think of that as 0.92 over 1, because, and that makes sense too. This is larger, but this is almost the same size, so 0.92 to the size of 1. And then finally, what haven't I compared yet? Oh, the opposite over the hypotenuse. So my opposite is 20. My hypotenuse is 51.2. So 20 over 51.2. And that comes out as, I've got it written over here somewhere, 0.39. Okay, which makes sense. This is less than half, so this should be less than 0.5. And I can think of it as over 1. Okay, how might this be useful? This might be useful in the following ways. Maybe I want to, I've got, once again, this is a smaller version of that triangle, so the similar triangles. Maybe I want to find this adjacent side, and I know the hypotenuse. Or maybe I want to find this opposite side, and I've got the thing that's right next to the 23. Both these can be solved kind of in one step, okay? As long as I know these magic numbers, these magic ratios, okay? This one right here, this is for the 23. This is my adjacent. This is my hypotenuse. So I need to say, okay, for all triangles, what's the relationship there? Adjacent over hypotenuse, this is right here. It's like if I had 0.92 to 1, once again, this is adjacent over hypotenuse. And so what I have here on the other side, this is a triangle with a hypotenuse of 1 and an adjacent of 0.92. In this case, I have a hypotenuse of 10, and I don't know my adjacent. But I can cross multiply, and this is a really easy one. When I cross multiply, I get 9.2 equals 1x, or just, that's the answer, 9.2, which makes sense. If this is 10, this is very close to that number. Look at our original numbers, 51, 47.1. These numbers should be very close together, okay? Last one, almost done. This is 23. This is x and 5. So this is, let's see, this is from this angle. This is opposite. This is the adjacent. If I go back up here, my opposite over adjacent ratio was, my adjacent was 1. My opposite would be 0.42. So I'm going to do 0.42 over 1. And once again, we're doing opposite over adjacent. And then in this particular problem, my adjacent is 5, and I do not know my opposite. So I'm going to cross multiply and solve. And I get, 0.42 times 5. I think I did this already. 0.42 times 5 is 2.1, and then 1x. And notice these came out as 1x. In some cases, we might end up with a number over there, which we had to divide, but it's all stuff you've done before. Now, that seemed like a lot of work, especially to figure all this out. If only someone had figured this out for us ahead of time and put them all in a table. That would be super helpful. Thanks. Bye.